We will be continuing on our lesson from last time. If you recall, we did not finish. Okay, so we are going to start with several topics, and the first topic that we will cover is something known as piecewise functions. Can you guys see that? The marker? Cool. All right, beautiful. Okay, I'm not 100% sure. I was speaking to some of the classes from yesterday, and some of them said they did see it in Algebra 2. Some of them were like, I've never seen that in my life. So I'm going to ask you, do you know what a piecewise function is by any chance? No? No big deal. I promise you it's very simple. So I'm going to give you a definition, and then we'll try an example. So it is a function that is defined by two or more equations over a specific domain. Okay, so once again, a piecewise function is a function defined by two or more equations over a specific domain. Okay, do you kind of understand that just by reading that sentence or not? No? All right. Well, let's jump in, and I'm going to show you, first of all, what does a function look like? What does the equation look like? Okay? So we're going to jump into an example, and I'm going to say, all right, let's say that I tell you that f of x is equal to, and you are used to this notation, right? F of x, right? That's nothing new. Okay? What I am telling you is that you're used to, like, for example, me saying f of x equals to 2x plus 1, or f of x equals to x squared, or f of x equals to square root. You're used to that, right? But if you look at the definition, it says there's going to be two or more equations. Okay, so here's the difference. You're going to have these braces that look like this. I don't know if you remember when we talked about this symbol last time. This symbol means the set. There's going to be a set of equations. That's why I have equations. Now, it says it has to be at least two. It doesn't have to be two. I'm going to use three for the sake of covering several things and the same problem. Okay, so the first thing I'm going to cover is that I have an equation that is linear. Right? How do we know this is linear? What's the power? 1. It's linear. Cool. But here's the thing. If you look at the definition, it says it is a function that's going to be defined over a specific domain. So I have to tell you when it's defined. And the way that I tell you is I'm going to put a semicolon. So this means x plus 6 such that x is less than 2. What I am telling you right now is that when I graph, which I am going to ask you to graph this, is that the only part of the graph that I will be graphing is when the values are less than 2. Fair enough? All right. Then there is another equation. This equation is just y equals to 3. Do you know what y equals to 3 looks like? This is the constant function, right? Such that x is greater than or equal to 2, but it is less than 5. Are we good so far? So I'm not going to graph the entire graph of 3. I am only going to graph 3 between the values of 2 and 5. Cool? And I'm going to throw a third one, and that's where we'll end. The third one, actually, let me change. Did I put 2? Actually, no, that's fine. We're good. I'm going to try, let's go with the square root of, let's go with x minus 4 such that x is greater than or equal to 5. We're good? Okay. I am telling you that this is the entire function. So this set of 3 equations make one function. They're not 3 separate functions. Are you guys with? Okay. And the reason why they're not 3 separate functions is because I'm restricting the domain. If I do not restrict the domain, what's going to happen when I graph all 3 of this? I'm going to have a lot of lines, I agree. Would it be a function? Why not? it wouldn't pass the vertical line test because you're going to have multiple points repeating itself, and it's going to fail the vertical line test, so I would not be able to call it a function. So if I'm going to call it a function, it better pass the vertical line test. You with me? Okay. So from yesterday, I kind of found out that unfortunately for you guys, and I do mean that unfortunately, your Algebra 2 teachers allowed you to use the calculators way too much. And I found out that a lot of you guys do not know how to graph at all without the use of a machine. That's going to be a problem because this class is completely without a calculator for the most part. So, if that's the case, please pay attention because I am about to show you how to graph without a calculator. Okay? Beautiful. First things is I got to draw myself an x and a y axis, all right? So here's x, here's y. Okay, I need to take you back to Algebra 1. For some of you guys, that was like a couple of years ago, all right? Cool. Do you remember what was the strategy that you were taught in Algebra 1 when graphing by hand? Yes. Was it right with a line? If it's a line, yes. But unfortunately, if it's not a line, it's not going to help us. Cool? So it's even before rise over run. Yes. Find what, I'm sorry? Finding intercepts? Yes, that goes along the lines of what you're saying. If I know intercepts and I know rise over run, if it's a line, then I can go about it. But if you can see, I don't have a line. Like, one of this is not a line. So that's not going to work for either one. Yes. Bingo. The first strategy that you were taught for any algebra function is to make a table. Okay? And that's what we're going to utilize. So if you've never learned how to make a table, this is your chance in pre-cal to learn how to make a table. Cool? So I'm going to make a table here on the right-hand side. How does a table work? You have to select values of what? You have to select x's, and then the function gives you values of y. Are you guys with me? So I am interested first on this line over here, x plus 6. Cool? Now, I know it's a line because it's a power of 1. And if you recall back in Algebra 1, all I need is 1 point and the slope, and I'm good to go. Are you guys with me? Now, there's 1 point that I'm very interested on right now based on this equation. I am interested on what is happening at 2. You with me? So what I am going to do is the first value that I am going to utilize is the x value of 2. Once you've selected your x value, you're going to plug it into the function. Now, because this is a piecewise function, you have to select the correct function to input it. The correct function to input it in this case would be the function of 3, because that's where you're equal to, right? But bear with me. I want you to plug it into this one just to figure out where you're at on this equation. You with me? So if you plug in a 2 here, what would you get? 8. Here's what this means. You ready? You are going to go into your coordinate plane, and you are going to plot the point 28, but you're not really going to plot it. And here's what I mean by that. You ready? So I'm going to just kind of estimate this is 2, and I'm going to estimate that this is 8. When I go to 28, I'm actually going to put a little open circle because I'm not actually there, because this is telling me that I need values that are less than 2. 2 is definitely not less than 2. Fair enough? Okay. Now, you mentioned the idea of rise over run, which has to do with slope. Looking at the linear function that I gave you, what is the slope of x plus 6? What is it? 1. How can I utilize the slope to come up with another point? Cool? So I can go rise, you said rise over run, I can go rise 1 to the right 1, but I want you to think this through. If I rise 1 and I go to the right 1, do you see how that's going to put me an x value that is actually bigger than 2? Which I don't want that. So I want to go in the opposite direction. So instead of rise over run, what am I going to do? Drop 1 and go to the left 1, which would put me at what location? 1, 7. If you're like, dude, I don't like that. Okay, you ready? X equals 1. 1 plus 6, 7. Now, you know this is a line, right? You know what a line looks like? Beautiful. I'm going to connect it, and I'm going to go in that direction. Right? Do you understand why I'm connecting it to the left side and not to the right side? Are we good? Okay. Now that I have the line, I'm going to move to the second equation. You told me that you know what y equals 3 looks like, right? But I'm only interested in graphing it between 2 and 5. Do you know what that means without having to make a table? Okay. If you're not sure, what it really means is when I go to this function, if I plug in the value of 2, 3, 4, and 5, what am I going to get? 3, 3, 3, 3. Always 3. Why? Because it's constant. Are you guys with me? So, at the value of 2, I'm going to label this as 3. I'm going to have an actual closed circle, right? Because that's where I'm actually equal to 3, right? And I'm going to continue going all the way till I get to the value of 5, right? So at 5, question. This inequality is telling you less than. So should you have a closed circle or an open circle? Open circle. Are you guys with me thus far? Yes? All right. Which then takes us to our last equation, which is the square root equation. Cool? We went over the parent functions last time, so you have an idea of what they look like. Keep that in mind to help you. But if you think about it, if I want values that are greater than 5, there is one value that I should probably input into my table right now. What is it? 5. Why do I care about 5? Because I'm equal to it. Okay? So if I input 5 into the square root equation, what do I get? Square root of 1, which is equal to? What's the square root of 1? Okay, cool. I was like, wait a second. I was like, 1. All right, so I have the point 5 comma 1, which it's going to be about right here for me. And it's going to be solid, right? Because it's actually a point. Because I'm equal to 5, right? Now, this is where it's going to get a little bit more complicated because we don't know the square root of every number off the top of our heads, right? So we are going to have to plug in some more values. According to this inequality, I can only plug in numbers that are bigger than 5, right? So let's do trial by error here. If I put in a 6, 6 minus 4 is 2. The square root of 2 is not something that I know, so I'm going to skip that. Cool? 7. 7 minus 4 is, do I know the square root of 3? No. Okay, 8. Okay, so can I use the value of 8? Beautiful. So if I plug in 8, 8 minus 4 is 4. The square root of 4 is 2, which means I have the point 8 comma 2. So I'm going to say this is 8, and I'm going to say this is 2 for me. Cool? Which means you have to recall your parent functions. Do you remember what the square root function looks like? And if you don't, I'll give you a little reminder. The square root function looks something like that. So that means this is going to look something like that. Yes? In other words, if you know your parent functions, after you plot points, you can use your knowledge of what the general shape is when you connect the points. Cool? So, real quick, just making sure this is not part of the graph, right? Like I was just extra stuff. The graph, the final graph looks like this, right? You have a line that's going down in this direction. You have a line that's constant here at 3, and then you have the square root function going in this direction. Okay? Your strategy, again, if you're looking at this, because I'm looking at a lot of faces and you guys are like, oh my God, I'm kind of a little worried about this, you have to learn how to make tables. Okay? And if you need help, you need to reach out like immediately. Okay? If you know how to graph without tables, even better. Cool? All right. With the graph now in front of you, I am going to ask you the same things I asked you about parent functions. So in other words, looking at this graph, you should be able to tell me what the domain is. Can anybody tell me what it is? What is it? It is negative infinity to positive infinity. Or, if you like, you can say all real numbers. Okay? I will accept either one of those. Cool? Does anyone not understand how it's negative infinity to infinity? If you don't and you're embarrassed to ask, I want you to look at the, remember domain has to do with x, right? If I'm using all the values that are less than 2, and then all the values between 2 and 5, and all the values after 5, isn't that literally like every number then? Beautiful. Okay. What about the range? Okay. All real numbers? No, I disagree. I don't know if anybody said that. I'm sorry. It's not all real numbers this time. Or is it? Actually, I'm looking at this graph, and I think it might be all real numbers. Let's talk about this. Okay? Range has to do with what values? The y values. Okay. There is one part of this graph that I can definitely analyze to show that it's definitely going forever down. The left side. Forever down means that I'm forever going to go to the negative numbers, so I can for sure say that it's negative infinity. Are you guys 100% about that? Yes? Now, I'm interested now as I'm going up. So as I'm going up this graph, so I'm going up, I'm definitely reaching 8. Do you guys see that? So maybe some of us thought like, oh, 8 is the highest I can get to. Maybe. But I'm like, hold on, keep going on your function. Well, your function now all of a sudden jumps over here. And it's only at 3, which is like, okay, well, I've already included 3, so who cares? Now it jumps, right? But now look at this part. It's going up. Will this go up forever? Yes, it will. So even though it doesn't look like it, it actually is going to go up forever. Very slowly, but it is going to go up forever. Therefore, for this one, we are looking again at an all real numbers. Okay? Good catch. Are we good? So far? Yes? Okay. What else did I ask you last time about parent functions? Domain, range, what else? Intercepts. All right, let's look at it. You actually have a drawing of it, but it's not very obvious, so you need to be able to figure out this algebraically. I need to figure out where my x-intercept is, which I can clearly see there is 1. Yes? You guys see it, like at least see that there is one piece of the graph touching the x-axis. Now, are you 100% sure what the number is by looking at it? No, but you should be able to know how to find an x-intercept because you've already taken Algebra 1 and Algebra 2. How do you find an x-intercept? You do not plug in 0 for x, you plug in 0 for y. Okay, but now here's where the graph really helps you. Which of the 3 equations is the one that's touching the x-axis? The x plus 6, which means I'm going to take the x plus 6, and I'm going to put x plus 6 equal to 0. Are you guys with me? Therefore, my x-intercept will take place at negative 6. Therefore, my x-intercept is set to be at negative 6, comma 0. Cool? All right. Is there a y-intercept? Cool. How do I find y-intercepts? 0 for x, or if it's visible, great. But once again, I think plugging in would help. Which equation would I plug into? The x plus 6. So 0 plus 6 is? So my y-intercept is at 0, 6. Yes? The what, I'm sorry? The x-intercepts, it's located at this location, which means when you look at a point, you have to have an x and a y, right? If you're on the x-axis, your y has to be 0. If you're on the x-axis, I'm sorry, it has to be 0. Therefore, you take your equation, which in this case is x plus 6, and you set it equal to 0 because the output is your y value, and your y value has to be 0. So you are looking to what x value would make the y 0. So that's why I'm setting it equal to 0. Subtracting 6 gets you the x, so that tells you that a negative 6x gives you a y value of 0. And you can check. If you plug in negative 6, negative 6 plus 6 is 0. And that's why that's our x-intercept. Cool? All right, beautiful. Y-intercept, we plugged in 0 for x, and that got us a 6. All right, the last thing we cover, I remember with parent functions, were increasing, decreasing, and constant, right? This got a little messy already, I know, but you guys can still see the graph, right? Where is this, first of all, is this increasing at all? Yes, it is. Okay, let's talk about the linear function, which is the x plus 6. Is that always increasing? Why do you say no? Because I disagree with you. the line. All I'm looking at is the line. The linear x plus 6. Is x plus 6 increasing always as far as what I'm graphed? Yes, it is. Tell me why. As x gets bigger, what happens to the y? The y gets bigger. So doesn't that mean increasing? Okay, I'm starting to realize some of you guys do not understand what increasing means. So increasing means as x gets bigger, y gets bigger. Yes, as x gets bigger, y gets bigger. Yes. Wait, hold on, I'm not done. Hold on. I know where you're going. I'm not saying, hold on, I haven't answered the question. I'm not saying that the whole function is increasing. What I am saying is that the function right now is increasing from negative infinity to 2. Tell me why that's true. From negative infinity to 2. As the x, think about a very negative x. As it goes from negative infinity to 2, what are happening to the y values? They're getting bigger. You guys see that? Right? And that's when he gets me to 8 right here. But then the function jumps to this 3. Tell me what's happening right here. Staying constant. So then I'm going to say I am constant from what value to what value? From 2 to 5. Now, I got a question. Should I put a parenthesis or a bracket along the 2? So in other words, is the 2 filled in or not? It's filled in, so I should put a bracket. Is the 5 filled in or not? No, so I'm going to put a parenthesis. Okay? Now, from there I jump down to here, right? You guys with me? Tell me what are the, down to here. What are the y values doing as x is getting bigger? So then after that, I'm also increasing, so I'm going to put a little u. And from where? 5 to infinity. With a bracket, because I'm including the 5, to infinity, which I'm not. Okay? And that is piecewise functions for you guys. Cool?